basic words in maths. I don't know what you're saying, please. Right. We have 3 lessons to do in calculus, and then we have some probability to do. So we're not too far away from the end. Anyways, some vocabulary just to help you out here. So I just want all the different ways we can say each of these. So the first one we have good old x plus y. But what else could we say here?
Sum of x and y.
Yeah. Sum of x and y. What else? Yeah.
X and y.
Yeah, x add y. Addition of x and y. Anything else? Huh? Yeah, total, yeah. Okay, what about this one? What's all the terms we have for this one? Well, there's x minus y. What else? Difference between, and take away, yeah. Difference between x and y. What else? X take away y. Anything else? X subtract y. And the last one, you'll like this one. Y from x. You say it backwards. Substitute? No. Wait, what about this one? X times y. X multiply y. Product of x and y. Yep. Yeah. Anything else? Yeah. XY. Anything else? X by y. Okay, this one? X divided by y. X over y.
X on y.
No. Quotient, yeah. Oh my goodness, I spelled quotient. Yeah. I know, you're just annoying me. Quotient of x and y. And finally, there's one more here. X of y. No. Good. But oh goodness, no. We won't do that. Huh? Nah. X to y. Yeah, no. X to y. No, definitely not. Y into x. Yeah. Huh? Well, it just came up when we were looking at the practical problems. Maybe people don't know all of the ways to say this. It's just useful for the practical questions in the exam of calculus and trigonometry and so on. Just expand your vocabulary.
Is that a quotient?
Yeah. QUO, yeah?
For the subtraction section,
Yeah.
did we say x negates y?
No, but we could say x less y if you wanted to. Huh? Yeah.
Could you make a question using y from x?
Yeah. What is 2 from 10? 8. 2 from 10 is 8.
Does the from become
Huh? From?
becoming 10, what's 2 from becoming?
No, that doesn't sound right. Just what's 2 from 10? Okay. Yeah. I suppose you could also say x take y if you wanted to. You can tell how old someone is by which one they use. Older people will use this one. More international, younger people will use this one. This is in between. So it's just a style almost. This would be the oldest way to say it. And you can see this one is not really popular because you have to say it backwards, which is not nice. Yeah. Same goes for this one. You have to say it backwards. Again, not nice. Okay. We got these words? Yeah. So we can start the next topic now. Okay, so what we're looking at now, you can write this down please, is indefinite integrals, also called antiderivatives. So we can just write this down. Very, very easy lesson to begin with. Yeah? You got that? Yeah? Okay. So, previously in math class, we learned how to differentiate. For example, x squared, its derivative is 2x. D for derivative. What we'd like to do today is go backwards, so that the antiderivative of 2x is x squared. But there is a small problem. The derivative of x squared plus 1 is 2x. And the antiderivative, we want it to be x squared plus 1. So, I hope you can see that there's a small problem. When we differentiate, it's very difficult to know what was the constant, because the constant has gone. So, what we say is the antiderivative of 2x is x squared plus a constant. And we have no idea of knowing what this constant is at the moment. So often we just write this as x squared plus c. So all the antiderivative is, it's just the derivative in reverse. You take the answer and you work back to the original. So the symbol we use to represent that is this with a dx. And whatever we want to find the antiderivative of, we write it inside the brackets here. So this means antiderivative of 2x. So this is like start and this is like end, and everything that's in between we anti-differentiate. So as our first example, the antiderivative of 2x, it was x squared plus c before we differentiated it. So this is like a basic example. we'll look at what the rules are here, but all the rules are just the same rules except backwards. You do everything in reverse to go backwards. So if you can just write this down, please, to get started. Yeah. So this first lesson is so easy, I think we'll get the next 2 lessons done in the first class. Because all we're doing here is practicing using the rules to anti-differentiate. And like I said, all the rules are just the same rules except backwards. So we'll make a table here. So here is the function, and then we shall anti-differentiate. Now, for your vocabulary, a synonym for anti-differentiate is integrate. So integration means anti-differentiation, reverse differentiation. Okay, so the first one is x with a power. So if you think about the differentiation rule, you bring the power down and you reduce the power by 1. Let's use that backwards. Bring the power down, reduce the power by 1. So instead of reducing the power by 1, we increase the power by 1. And instead of putting the power in the front, we'll put it over the power, yeah. Okay, so that's our first rule. What was the derivative of sine? Cos. So the antiderivative of cos is sine. And likewise, the antiderivative of sine is minus cos. Now let's look at ekx. What did we do here when we differentiated? We brought the power down in front. So here, what do you think the anti-rule is? Yes? Divide by the power. Very good. So bring the power under. Do you remember what the derivative of log x was? 1 over x. So the antiderivative of 1 over x is log x. And the derivative of tan x was 1 over cos squared x. So the antiderivative of cos squared x is tan x. And final rule here is 1 over, it's a new rule, 1 over ax plus b. The antiderivative here is 1 over a log ax plus b. Now all of these have a plus c in them as well, of course. Okay, please copy this table into your notebook. Yeah, you have this, yeah? Okay. Let's have a look at some examples. We'll integrate a cubic as an example, and then something a little bit more difficult. Can I scroll down? Yeah. Okay. So, we want to integrate, let's say, 3x cubed plus 4x squared minus x plus 1 dx. So let's integrate. The rule is you increase the power by 1 and divide by the new power. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. And what will 1 become? Not this one, no. 1x. Because it's a bit like x0 here. Plus c. Okay, what about this one now? Integrate 1 plus 1 over x plus 1 over x squared. I suppose you can pass it. Me like. Colin, did you return the broken one then? Are they giving you a refund, or are you going to bother? Or?
Yeah, refund. Okay.
They don't want it back, they just gave the refund. Nice. So what's the price difference? Okay. I think it's worth it. Now we can use the projector and CAV. Huh?
I hate to
What?
break it to you.
What?
You don't really care.
Maybe you don't care, but I'm sure someone cares. At least I care. Do you care? See? It's a lot. What do you need me to go to? The table?
Yeah, the last one.
I don't know where it's gone now. There. Do you know what, actually? I think you're jealous. I think that's what it is. You can't use the projector and CAV and I can. I think that's really... Deep down, I think that's what it is. Just leave it here. Alright, you got it? Okay. Okay guys, can you just try this one here? And I'll give you a little hint. This one you need to rewrite. X power minus 2. You need to put it a different way.
Yeah, but why do we rewrite the one on the left, one on the right, but not the one on the left?
Because
This
the
one?
in the middle you can just make it a...
Yeah, you have a rule for this already.
Yes, but if you change it, if you rewrite it...
Go on, see what happens. No,
Zero. Right?
What?
no, try it. It'll be a good experience for you. Okay. So this I should rewrite as 1 plus 1 over x plus x minus 2 dx. So what does 1 become? X. 1 over x? Log x. And then this one is increase the power by 1, divide by the new power, plus c. So the answer is x plus log x minus 1 over x plus c. Now, let's see what happens with Yusuf's idea here. So, if you were to try and rewrite this, you would get this. Yeah. See, wasn't that a good experience? Yeah. So, increase the power by 1, divide by the new power. And this is quite the problem. So, when we have 1 over x, we're happy to leave it as 1 over x because we have a rule for 1 over x. Yeah, so let's do another example. Can I scroll down?
How do we turn it to -1 over x?
Minus 1 over x? Oh, you mean here?
Yeah.
Well, it's x power minus 1, which means 1 over x. And the minus 1 down below, I can put it in the front.
Can you turn that into
Turn what into log? 1 over x? No, because we've already integrated. We can't turn it into log. It turns into log when we integrate. We've already integrated, so we can't integrate again. Okay, can I scroll down? Yep. Right. Try this one. No, let's make it a bit harder. Yeah, that's better. Try integrating this. The fourth teacher that passed through this classroom. Clearly no respect for me.
It's my bad influence.
You're following him, is it? Yeah. Clearly. We know who the troublemaker of the two is. Okay, some people have answers. Do some people have right answers? Let's have a look. So the first thing I'll do is I'll change this into x minus a half plus ex power minus a half as well. So this is x minus a half plus e minus a half x dx. Now I can use my rule. Increase the power by 1, divide by the new power. And the rule for this one is to divide by minus a half. So when we simplify this, we get a half root x. No? Oh yeah, what am I saying? Sorry. Of course. I was just so excited about my new connection. 2 root x minus 2 over root ex plus c. Now in the exam, you do not need to go back to this form. Often they are happy for you to leave the answer like this. Very rarely, but it does happen, but not often, very rarely they ask you to write the answer back in this form. But 99% of the time, you are good to leave the answer like this. Yep. In the exam, they don't care. You get full marks for either form. But if they wanted it would be to write it in this form. So what they would say is, in the question, they would say something like, write it in the form of a root x plus b over, like they would say specify what way they wanted. Or they might say in the question, no, actually, if they said exact, both are exact here. Give it in
the form A, they find A and B.
Yeah, that's what they say. Or they might say to write it in third form, to have the roots in there. You know? Yes.
Root E.
Yeah. Root E minus x.
Right maths or wrong maths?
Right maths.
So this is what I do.
Yeah? Oh yeah, this is the same as root E minus x. Yeah. Okay. So not that difficult today. We're just using the rules. So I'll let you work on these for a couple of minutes and then we'll start the next lesson. I would like you to do...
110.
Let me think. I want... Be quiet. I'm thinking. Question 1. A to F. Question 2. A to Z. Boom. Question 3. You don't have to do it. It's just 1 and 2 we need for the exam.
That's it, they don't have to define C? How disappointing.
They do ask us to find C, but it's a semester 2 thing, which I know seems strange because it's not difficult to find C. So you will do that later with me. No, I'll leave it. Okay, so if you can do these for a few minutes, A to F and A to Z, just 5 or 10 minutes, and then we'll start the next lesson then. And I think we should have some time then to get in the third lesson as well, actually, which means we'll have integration finished today. Although the third lesson is a bit difficult, we might have to split it into 2 halves. So if you can do these for a few minutes.